All right. So do you remember where we were discussing in the last class? Like what were we discussing in the last class for that matter?
Carbon and its compounds.
Carbon and its compounds. That is a very nice start we have had in the last class, isn't it?
Yes, ma'am.
Yeah. So let's take a look on what we have already learned, and then we will move on to the next one. Can you all see the screen? No.
No. Now it is visible.
Yeah. All right. Okay. Okay. So now that's a slideshow kind of, isn't it? So carbon, we talked
Ma'am,
about.
I can see the slideshow.
Oh, okay. So I asked you about reminding me of something in the next class, kind of like that, isn't it? For something. I wanted you to ask for me for something. What was that? Do you remember?
Notes.
Notes 4, not just notes, notes 4. Hybridization, isn't it?
Yes.
All right, okay. So it's important that you read the notes before you enter into a class, okay? Otherwise, you won't have a clue where we started. You won't have any head or tail of what is being taken. Okay. So keep this in mind. Just read. Uh, just read things, okay? Just read what is given to you in the notes. It is only going to take you 10 minutes, not more, isn't it? Okay, the notes are like what? 5 pages or 6 pages? Can you just tell me? Anybody? Last class notes? Did you take down this one? Let me show you. Let me show you the slide. Can you all see the screen?
Yes, but that is not in slideshow.
Not in slideshow. Not in slideshow. Yeah. But have you taken this in your notebook? This one? Can you see the screen, all of you? Srihari and Sri Lakshmi.
Yes. But I think we have drawn a picture like that. One
Okay.
minute.
Not this notes. This piece of note will not be in your notebook.
Yes.
So you can start taking down the notes from this point onwards. Srihari, you can start from this, okay?
Yes, ma'am.
Yeah. So if there is any doubt, just ask me, okay? Once completed, I want you to give me a thumbs up, okay? Okay, Sri Lakshmi, I can see your thumbs up. Srihari, what about you?
Ma'am, the last point.
Okay. So once completed, just tell me, okay?
Completed.
Okay. Okay, done. Good. So here is sp3 hybridization. That means all the 4 orbitals are mixing up to give what happened, Srihari? You have a reason?
Ma'am, I can't see the slides.
Okay, okay, just a moment. Okay, here it is.
Yes.
Vijay, good evening.
Good evening.
Okay. So Vijay, this is what where we stopped in the last class. I wanted you to take down notes in the first place in the beginning of today's class. Do you remember? Can you all see the screen, Vijay?
Yes, ma'am.
Yeah. Okay, you can start taking down the notes because this is what we had some leftovers with in the last class. Once completed, give me a thumbs up. Okay, Sri Lakshmi, Sri Hari, Vijay. So remember, this is like, okay, Sri Hari, I can see a thumbs up. Very good. So remember, this is what it is. That is, carbon has its outermost shell, that is L shell, second shell, containing one s orbital and three p orbitals. That means subshells. Okay, orbitals, one s orbital and three p orbitals. All of them are mixing up together to produce. Okay, what is emerging? Emerging thing is they become, yes, Vijay, they become four equal energy holding same shaped lobes or orbitals, which are oriented in four different directions. Okay, and their energy is the same, their shape is the same, they are hybrid orbitals. Okay, so they have characters in the sense one s orbital is involved, three p orbitals are involved. So 1:3, 1 plus 3, you can mix it up. So 25% each orbital of these four new hybridized orbital, each orbital is possessing 25% s character and 75% p character. Okay, sp2 hybridization. Similarly, 33.33% of s character and the rest is of p character. Only 3 hybridized orbitals are formed. Why? One of the p orbital is refusing to involve in hybridization. Rest of the 2 are involving in hybridization as well as the s orbital. This is what happening. I think it is clear for you, the idea. I guess you can all hear me, right?
Yes, ma'am. Clear, ma'am.
All right. So take down the notes and we will go to the next. Once you are done, you can give me thumbs ups, okay? Done, Srihari? Okay, Srihari, I can see a thumbs up. Sri Lakshmi?
No, ma'am. Can I
Okay,
take the
okay.
picture?
No. You can take down the notes. You can continue writing, not an issue. You can write it down, okay? You don't have to take a picture or something. Okay, now about sp hybridization. Okay, here it is. Once completed, give me a thumbs up. Okay. Anybody yet to complete? Srihari, I saw your thumbs up. Okay. Vijay, what about you? Okay, Sri Lakshmi and Vijay. Good. This you don't need to know. Okay. So that's it from that one. Now here we have to deal with can you see the screen?
It's loading for me, ma'am.
Oh, okay. Now,
Yes, ma'am.
yes. Okay, Srihari and Sri Lakshmi, you can see this too, right?
Yes, ma'am.
So we were
Ma'am,
talking.
I can see.
You can't. Okay. Now, Srihari, can you confirm?
Ma'am, no, ma'am, I can't.
You cannot. Okay. Srihari, now I have loaded it again.
Ma'am, no, ma'am. Still
No.
loading.
Can you just refresh your connection or something?
Ma'am, I'll leave and join again.
That's better. Okay, so in the last class, we were again dealing with allotropes of carbon. After that, we headed into hybridization, isn't it? I have explained what is hybridization, how it is happening, and its details also. Now you have just taken down the notes about it. Okay, Srihari, I can see that you can see the pages now. Good. So types of carbon compounds, they are what? Saturated and unsaturated compounds. Of these, you have alkanes, you have alkenes, you have alkynes, which means one of those is completely filled with single bonds alone. The other one will have at least one double bond, that is alkene. Alkyne will have a triple bond, at least one triple bond. Okay, between carbon and carbon, between two carbon atoms, that is important. And it is not only that you have to see alkenes, alkynes, and alkenes, alkanes, and alkynes alone, not that. But at least this is a good start. Okay, a start with hydrocarbons. Okay, so about hydrocarbons and about other compounds, we are going to learn in detail. That will be not in your 10th class, but still you will be learning it sooner or later. But we will just have an introduction, or have some bits and bits of tidbit kind of things from this chapter, like which functional group for which kind of compound, kind of like that. You can match what is the group that appears in a compound and what does that mean for the character. Okay, the group and the character, kind of simple things that we will learn in this class. Okay, ready?
Ready.
Okay, so types of carbon compounds, we have dealt with this in the last class, I guess, isn't it? I just told you what is alkane, what is alkene, and what is alkyne. Did I? Like I have shown you what is the single bond, double bond, etc. Triple bond. I show you ethane, ethene, and ethine. Do you remember the three compounds? Vijay, Sri Lakshmi, Srihari. Do you remember? Okay, so let us refresh our memories anyway. Can you all see the whiteboard?
Yes, ma'am.
Yeah. So this is it. That means alkane means full of single bonds alone. Okay, so carbon is bonded to other carbon atoms with single bonds alone, like All
this
the,
has formulas also, ma'am.
what is it?
This has some formulas to find, ma'am.
Formed?
For alkane form, like there's a formula like CnH2n
Ah,
plus
yes,
2.
the formula. Okay, the general formula is,
Yes,
all
ma'am.
right. The formula for this alkane is CnH2n plus 2. Okay, that means how many number of carbon atoms are there? That number into 2 plus 2. That means that is the number of hydrogens for a saturated long chain compound like this. One of the example. So 2 into 4 plus 2. What is it?
10.
C4H10.
C4H10. And this
Okay,
is
so
butane.
that is butane. Okay, butane, good. So see, I want all of you others like Srihari and Sri Lakshmi, just count the number of carbon atoms and hydrogen atoms. This will be the result you get. Okay, 4 carbon atoms are there. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Isn't it? So that is how we find the formula for alkane. So alk, this prefix can be anything according to the number of carbon atom. If carbon atom number is 1, then it is meth. Okay, carbon atom, number of carbon atom n is equal to 1 means then it is meth. N is equal to 2 means it is eth. N is equal to 3 means it is what? Just a moment, students. Something went wrong. Okay. So n is equal to 3 means it is prop. N is equal to 4 means it is but. Okay. N is equal to 5 means it is pent. 6 means hex. Okay. 7 means hept. 8 means oct. 9 means non. And this like NON we will say, put the E in bracket. Some places we use E, some places we don't use this E. Okay. Next one is deck. Okay, clear? So in this case, Sri Lakshmi, what will be the prefix? Instead of alk, you have to use something that stands for N is equal to 4. What is it?
Butte.
But. And it is an alkane, a completely saturated compound. So you have to use ane as the suffix. So butane. And this is what we use in our cooking gas like LPG is butane, liquid butane. Okay, clear? Anybody having any doubts with this? Any doubts? Srihari, Sri Lakshmi, Vijay?
No.
No doubts. Okay.
No doubt.
Next points, good. Next point is, I have already given you this like CH3, CH2, CH2, CH3. That stands for this one. This is what I wrote, isn't it? The picture. Okay, this is what you saw, isn't it? Same thing, you can write it in this pattern. Okay, CH3, CH2, CH2, CH3. Or even you can make it short like just this. Okay, how? Because this terminals means CH3. Okay, and inside whatever curve, whatever is the corner, it is CH2. Okay, guys, got it?
Like different arrangements, ma'am.
Depend on the arrangements, of course, but Still, this is the dash line format of writing. Okay. Of representing organic compounds like this, simply like this. This is also butane. Representations of butane. Just for your information. Now, let me ask you, this is not why I started a new page, okay? The reason for starting a new page is something different. Instead of one hydrogen in the middle carbon atom, I am going to substitute that hydrogen with another CH3.
Like ionization form.
Not ionization. It is known as isomerism. Okay.
Sorry,
Let us
ma'am.
go.
The
Yeah.
II for
All right. Isomerism. So it starts with I, that is what you remember, isn't it, Vijay? So it is isomerism. And isomerism or isomer, what is an isomer? Can somebody else say? Tell me, Shri.
Same molecular formula but different structural formula.
That's it. Okay. A compound that is having a same molecular formula but a different structure is known as isomers. Okay. Molecules or compounds. Okay. That's better word to use. Compounds having same molecular formula but different structural or structures are termed as isomers. Okay. So why the compound is different? Okay. Are you familiar with the second compound I have written? Yes.
Note of this.
yes, ma'am.
Yes. You have to take down the notes. Yes. Okay, Srihari or Vijay, what were you about to
The
say?
one before butane.
No, ma'am. I told I understood what you.
All right. Okay, Vijay. Sri Lakshmi, the point is you have to take down from the board. That's it. Nothing else. These are all just for the information. Okay, you have to know this at one point. Okay. Sri Lakshmi, clear?
Yes, ma'am.
All right. Okay, so by the way, we are talking about this particular compound. Okay, the one which looks like a pendant, kind of like that. Okay, so CH3, CH3, which has a pendant like substitution, that is CH3 again. Okay, now let me ask you, what is this compound? This compound is 2-methyl propane. Okay, 2-methyl, how to name it and kind of like that, you are going to learn in later classes. Okay, forget about that. Just know that this is 2-methyl propane, while what you have dealt with earlier is butane. But what is the similarity? Both has same structural formula. See, both have 4 carbon atoms and 10 hydrogen atoms. That is the irony. Okay, so that's how we look at isomers. Just for your information and example, I want you to take this down. Then we will go back to the original note which contains alkane, alkene, and alkyne. Once done from here, you can give me a thumbs up. Yes, Sri Lakshmi, I can see a thumbs up. Good. Srihari and Vijay, done? Okay, Vijay. Okay, Srihari. So here is the notes. Okay, types of carbon compounds, that is saturated, unsaturated, things like that. Okay. Next, introduction. As an introduction to organic chemistry, I can tell you that tetravalency, catenation, and that leads to the numerous compounds that I have already told you. I think I have given you this notes, isn't it?
Yes.
This I have given you. Saturated organic compounds, the pattern. This I haven't given you, isn't it? Saturated organic compounds, that is single bonded compounds, I haven't given you this note. So you start from here, types of carbon compounds, and then I will show you the other slide I have given you. Sunanda, good evening.
Good evening, ma'am. Sorry, ma'am, I got late because I was studying for my exams, ma'am.
Okay, exams are starting from?
Ma'am, already started, ma'am.
All right, okay.
English got over, ma'am. Science got over, ma'am. So now tomorrow for me Hindi exam, ma'am. So I had come
All
a
right.
bit late.
Okay,
Extremely
okay.
sorry, ma'am.
All right, that's okay, but don't skip your classes because you will lose track of what have been taught. Okay. Like
Okay, ma'am. I
losing
won't
track.
skip classes. Ma'am.
Losing track is the last thing you need when you are attending science classes like chemistry, physics, or mathematics, or for that matter, biology, whatever it is. Okay.
Yes, ma'am.
Yeah. So, Sunanda, you haven't missed much because we were like starting from the last class notes and all. Now we are discussing about the carbon compounds, alkanes, alkenes, and alkynes. So for a start, let us classify it into saturated compounds and unsaturated compounds. So saturated means all single bonds. Unsaturated means it can involve double bond or triple bond. As we have already discussed this in the last class. Same. Okay.
Yes, ma'am.
All right. So Sunanda, let me ask you, is that a terminal exam or something going on?
Ma'am, to say it's like a normal cycle test, ma'am.
Okay, okay, okay.
Ma'am,
All
like till what they have taught for us, they are just giving us like a small exam, ma'am.
Okay. So would be like in your class hours, you'll have to spend an hour
Ma'am,
or
like
something.
no, ma'am. The way it's like in the morning itself, first 2 periods will be exam, ma'am.
All right.
Then
Okay.
for the next exam there will be revision, and then classes will be going on, ma'am.
Okay. 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 Got it.
On Monday only my English, my exam is getting over, ma'am.
All right. Okay. Okay. Fine. Carry on. And do well in your examinations. You have to.
Thank you so much, ma'am.
Okay. So this is what happening with our carbon compounds. Okay. So Srihari, Sri Lakshmi, Vijay completed writing.
Yes, ma'am.
Okay, good. That's an energetic yes. All right, Vijay. Yeah, that's a thumbs up from you, Vijay. Good. What about you, Sri Lakshmi? All right. Sunanda, I expect you might have completed or not.
Ma'am, yes, ma'am.
Completed. All right, good. So introduction to organic chemistry, I have given you the notes in the last class. I think you have completed until this point. Can
Yes.
someone give me thumbs ups, all of you? All right, okay, all of you, good. Now we are looking at saturated compounds alone. That means we are looking at alkanes. Okay, alkanes. So they are like single bonded compounds. Their name alkanes. Their general formula is CnH2n plus 2, where N is simply the number of carbon atoms involved in that particular compound. That's it. Okay. Sunanda, you follow me?
Yes, ma'am.
All right. So this is how we look at it. You have to take down the notes, including the table. So give me a thumbs up once you are done. Okay. Okay, Srihari. Okay, Sri Lakshmi. So Nanda Vijay completed.
Completed.
Okay. Vijay. Okay, Vijay. Next one. It is about alkenes. That means double bonded compounds. Okay, double bonded compounds means at least between two carbon atoms. Between at least two carbon atoms, you have a double bond existing. So one of the bond is definitely a sigma bond. Sigma bond in the sense head to head bonds. That means the hybridized orbitals are directly involved. The other ones are the uninvolved orbital. You remember one of the p orbital is not entering into hybridization. I told you in the last class. Do you remember, all of you? So those are staying as such in the parallel position. So they are having a parallel side to side overlapping. Okay, sideways overlapping. It is simply like, okay, yeah, let me tell you an example. You are sitting in a class and the class is asked to stay silent for a few minutes. Okay, what would you do? You have to communicate with your neighbor and you are already asked to remain silent. What would you do? If you are sitting just next to the person you have to communicate with, what would you do? Simply you write something in your piece of paper, in your notebook, and show it to the other one. Am I correct?
Yes.
Okay, isn't it? You will take your rough book, you will write something that whatever you have to convey, you will write it and show your book to the neighbor, isn't it? What if you are sitting a bit apart, like two or three people are there in between? What would you do? Or one person is there in between, what would you do? You will simply write it in a piece of paper, you will fold it, and you will simply give it passing the middle one. Am I correct?
Yes.
Isn't it? Skipping the middle person between you and your friend, you will pass the paper. Okay. What if you are far apart? You will pass it, pass it, pass it, pass it, etc. And finally, it reaches the person. So likewise, here, head-on collision is not possible. Okay, directly showing the book is not possible. Okay, so what should be done? Sideways overlapping. You are skipping the middle one and passing it to the next person. Clear? Srihari, Sananda, Vijay,
Yes.
Yes.
able to follow? So that's what happening. That's what happening here. I want you to complete your notes and we will move on to the next. Once completed, please give me a thumbs up. Completed?
Completed.
Okay, good. Sri Lakshmi. Okay, Sri Hari. Sunanda Vijay. Sri Lakshmi, can you stay back after the class for a few minutes, 2 or 3 minutes?
Okay.
Okay, Vijay, I can see it. Now, unsaturated organic compounds, that is triple bonded compounds, alkynes. So the general formula is CnH2n minus 2. And it is like at least 2 carbon atoms. Between 2 carbon atoms, there exists a triple bond. That means one head on head, one of them like this, the other one like this. Here one sideways overlapping, here one sideways overlapping apart from the head on. Okay.
So unsaturated organic compounds of carbon are, it can be either alkene or alkyne.
It can either be alkene or an alkyne. Yes.
Yes, ma'am.
Yeah. Saturated alone is different. That means all the bonds are single bonds. Okay, take it down and we will move to the next. Okay. Please give me a thumbs up once you have completed. Okay. Okay, Sri Lakshmi, I can see a thumbs up. Completed, all of you. Anybody yet to complete? Please put on raise hand icon. Any reasons? No reasons. Shall we move forward? Okay. So structures, chains are there, which I showed you earlier. Rings are there, that is they are closed ones. Branches are there, branches also we have seen. So let us discuss about chains, rings, branches, few examples, and we will move on to the next. Okay. So let us take a few examples, only examples you need to know. Okay. So chains means straight chain. One carbon atom is bonded to another carbon atom. That carbon atom is again bonded to another carbon atom. Kind of like it is moving on. They are known as chains. So the terminal ones are always CH3. If all the carbon atoms are single bonded, the terminal ones are CH3 and the others are all CH2, CH2, CH2. Okay. If they are double bonded, if the terminal carbon atom itself is double bonded, the first one will be CH2, second one will be CH, then CH2, CH2, CH3. Okay. Now, if CH3, CH, CH3, CH2, CH3, kind of like this. This is a branched one. Okay. One of the hydrogen is again substituted by another carbon atom. Okay, so this is branched one. So for that matter, you have another option. Okay, CH, CH2, CH3. This can be another branch. Okay, CH, CH3, CH3. See, this can also be a compound. Okay. So these are few examples for straight chain and branched chain. About ring, CH2, 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 CH2. Okay, so this is cyclohexane. Can you all see the screen?
Yes.
Okay, so numbering is like we have to name, if we have to name one compound, we have to number the longest chain 1, 2, 3, 4. Okay, so 2 isopropyl, This is isopropyl group. Okay. Isopropyl group is attached to second carbon atom. That is what we are writing here. At 2 position, you have isopropyl group, and the compound which is holding this isopropyl group is butane. So that is how we are naming this particular compound. This branched chain compound is named as 2-isopropyl butane. This branched chain compound, the first one, 1, 2, 3, 4. This one is 2-methyl. This group is methyl group. Okay, so 2-methyl butane. First one is simply normal pentane. Okay, you simply write it as pentane. Second one is 1-pentene. Why 1-pentene? The first carbon atom itself is involved in unsaturation. So 1-pentene. Where can this double bond come? It can be either be here, or be here. Anywhere it can be. So you have to specify the position. This is how we are writing it. So is it clear, the idea? Any trouble?
Ma'am, can you explain this again?
Sure. Okay, so let us start from 1H. Okay, so single chained. Okay, straight chain compounds. You can start from that. Write down the heading as straight chain compounds. Okay, so one of the example is CH3, CH2, 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 CH3. Means simply pentane. You understand that, right? Because ane means it is an alkane, so it is ane in the last and 5 carbon atoms are involved, so pent in the first, isn't it? Srihari, are you able to follow?
Yes, ma'am.
Next one is CH2 double bond, CH2, CH2, CH3. So here, you know, this first position, 1, 2, 3, 4, 5. Among the 5 carbon atoms, the first position itself is the one which is involving in double bond. First and second, of course, but first one means obviously the second one is also involved, isn't it? If you specify the first one is obviously making this bond with second one. Am I correct?
Yes, ma'am.
Okay, so that is again pent 1-ene or 1-pentene. Both are correct. Both way you can represent it. So what about this CH3, CH2, CH2, CH2? What is the name of this compound? Anybody can guess? Let me give you a clue. You don't necessarily have to number it from left to right alone. You can go from right to left also according to the priority. If there is a double bond is getting the priority. So you have to number from that position with which this particular double bond is getting the lowest number possible. So what should be the name of this compound?
Ma'am, 1-pentene.
Exactly. Okay, so write 1-pentene and these two structures. It is important that you understand this point. Okay, clear? So now CH3, CH3, CH2, CH2, CH3. See, this compound has a substitution. So the substituted carbon atom should get the lowest number possible. So 1, 2, 3, 4, 5. And the second carbon atom is having that pendant, isn't it? So 2-methyl. What is the pendant named? It is methyl group. Okay, CH3 group with something to add up here is known as methyl group. So 2-methyl pentane. Clear? Is that clear? Anybody having any doubts? So no doubt. I want you to take this point down and give me a thumbs up. We will move to the next. Once completed, give me a thumbs up. Okay, Srihari. Okay, Sri Lakshmi. Okay, Vijay. Sunanda, what about you?
Completed.
Okay. So next is branched also we have dealt with. Now, simply a cyclic compound. That means CH2, 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 CH2. This means cyclohexane. Okay, both are cyclohexane. Okay, because each corner means CH2. That is obvious, isn't it? Or you can say like this. Each corner means carbon atom and count the number of bonds. According to the spent number of electrons, you saturate the other hydrogen atoms. That will actually give you the idea about how many hydrogen atoms are there and how to name the compound. Clear? Is it clear? Anybody having any doubts with this? So this will be cyclohexene. You don't have to specify the carbon atom number, because in this cycle this double bond can be anywhere. That doesn't matter, isn't it? Even if it is in this point or no and this point, or no, this is this point, anything, it is the same, isn't it? Got it? Okay. Srihari, Sri Lakshmi, Sunanda, Vijay, able
Yes,
to follow? Okay.
Yes.
And the center two carbons cannot have double bond, ma'am.
Center two carbon atoms. Which one? Anything you can have. Either
And the
this,
top carbon and the bottom carbon.
this one. No,
Yes, ma'am.
no. It should be the adjacent carbon atoms.
Yes, ma'am. So those two carbons does not have any bond, ma'am.
Like there is a compound with that. Okay. But that is not a direct bond.
Yes, ma'am.
But it is actually a bridge bond. There is a carbon atom in between. Such a compound is there existing. Yes, norbornene it is called. Okay, but you don't have to go for that complicated kind of a compound, which even we were learning in our what MSc class or PG class, kind of like that. Okay. So let's not go into much of a troubly detail. Let's keep it simple for now. Okay, so once completed, we will move on to the next one. Okay, Sri Lakshmi. Okay, Sri Hari. Okay, Vijay. Sunanda, what about you?
Complete.
Completed. Good. Now that our examples are almost completed, let us see one more thing. When this is the compound, you need to specify the numbers. One of the double bond, you start with the numbering 1, 2, 3, 4, 5, 6. Okay, so this point it will be like 1 comma, then you are going clockwise 4. Okay, so 1 and 4. Okay, then cyclohexadiene. What is this di? 2 double bonds are there at 1 and 4 positions. So that is what you are specifying. Or better say this as cyclohexa 1,4 diene. Clear? All right. So what should be this? Come on, name this compound, someone. Forget the numberings, just name this.
Ma'am, cyclohexatriene.
Okay, but the cyclohexatriene, the double bonds are in the alternating position and all. This compound is better known by its commercial name known as benzene. Okay, this is a natural product. Okay, this is benzene. And this is another branch of our compounds, organic compounds known as aromatic hydrocarbon. Okay, so just keep this in mind. So once completed, give me a thumbs up. And we will go back to the notes. Okay, Srihari, I can see your thumbs up. Sri Lakshmi, Sunanda, Vijay.
Complete.
All right, Sunanda. Okay, Vijay, Sri Lakshmi. Okay, Vijay, I can see your thumbs up. Okay, Sri Lakshmi, good. So it can form chains, branches, it can form rings that we have seen. Now, the rings or branches or whatever, maybe it can be some other groups like functional groups. Now we are gripping our hold on to the real core of organic chemistry. Simply up until this point, what we have learned is consider those as alphabets of a language. Now you are slowly starting to learn words one by one. Okay, got it? So slowly we are getting a grip on to organic chemistry. Ready with this? All of you.
Ready.
Good. So some functional groups, not all. Okay, I'm just giving you few examples. That is enough for you now. So functional groups means what? Functional groups in an organic compound enables it to show a specific or a particular character. Okay, for example, CH3 is ethane. Okay, this ethane C2H6 minus 1 plus OH. That means one hydrogen is removed, and instead of this hydrogen, OH group is getting substituted. OH group. I'm not saying about OH minus anion. No. OH group like this. Okay, it is getting substituted. Means CH3, CH2, OH, a straight bond. There is no ionization happening here. Understand that this oxygen is directly bonding with this carbon atom. Clear? And this OH group is known as hydroxyl group. Hydroxy group. And this compound which possessing, okay, the compound having at least one OH group attached to it is known as alcohols. Alcohols as in the real alcohol, ethanol, methanol, propanol, butanol. Okay, every alcohol you are familiar with the names. Okay, belongs to this category. CH3OH, CH3, CH2OH, CH3, CH2, CH2OH. So this is methanol, ethanol, propanol, etc. So which of this you have heard that we are like consuming, which is used for consumption? Any idea? Ethanol is the one which is consumed. Okay, methanol is poisonous. Ethanol is the one we are using to consume. Methanol is known as, better known as spirit, the one which you use for medical purposes. Like they will rub your skin before they are taking blood from you for blood works, isn't it? If you are undergoing a blood test, they rub some spirit onto your skin first to clean it, isn't it?
Yes.
That's actually methanol mixed in ethanol. Okay, rectified spirit. So that's just for your information. I want you to take this down. The first functional group you are learning is alcohol group. That is hydroxy group, that is giving you organic compounds alcohol. And once completed, I want you to give me a thumbs up. Completed? Any thumbs ups? Okay, Sri Lakshmi. Okay, Vijay. Srihari.
Ma'am, completed.
Okay. Anybody else to complete? Sunanda, Vijay, Sri Lakshmi. I want all your thumbs ups all at once. Completed. Okay. Next one is something you are familiar with. Okay. Let me ask you. I'm just giving you an example. Okay. CH3COOH, or better say CH3C double bond OH. See, have you ever smelled the smell of vinegar? Ever known the smell of it?
Yes.
And that is this one, this particular compound, and that compound is known as acetic acid. And this is when acetic acid, okay, is taken as 1% and the 99 portion is water, then this is your vinegar, the vinegar we use in our kitchen. Okay, got it? Okay. So this COOH group is known as acid group. Okay, you take that down to like this point. All right. And once completed, give me a thumbs up. So you have The same acetic acid is also known as ethanoic acid. Ethanoic acid. So there should be a methanoic acid, isn't it? That is simply HCOOH. Okay. The next one is propanoic acid, CH3, CH2, C double bond O, OH. This is propanoic acid. This is methanoic acid. Methanoic acid. So here it is. Okay, Sri Lakshmi. I can see your thumbs up. Okay, now completed. Completed, Srihari, Sunanda, Vijay, all of you.
Completed.
Okay. Vijay, I didn't get a response from you. That's why I'm waiting. Okay. Now, next one is when you have carbon that is bonded to another carbon having double bond O, the rest is hydrogen. This group, CHO group or C double bond OH, both are same. Okay. This group is aldehyde group. Aldehyde group. Just note one point down. COOH, this group is actually carboxylic acid group. Okay, carboxylic acid, that word we missed it earlier. Carboxylic acid group. This is aldehyde group we are talking about now. Okay, so HCHO, this is the first compound. Okay, CH double bond O. This is formaldehyde, or better say methanol. CH3 C double bond OH. This is ethanol. Okay. Another one is CH3 CH2 CHO, that is propanol. Okay, these are few examples for few functional groups. Okay. See here, this is one terminal, isn't it? Can you understand that? This is one of the terminal, and the other one is a hydrogen, not a carbon compound, isn't it? Carbon group is not arising. What if it is carbon group? Then this is not aldehyde at all. It changes. Next one is ketone. Okay, so we will discuss ketone now once you have completed with this. Completed? Okay. Sri Lakshmi, any reasons? Srihari completed. Sunanda, Vijay?
1 minute.
Yeah, sure.
Completed.
Completed. Okay, Sunanda. Vijay?
1 minute, ma'am.
Okay.
Completed, ma'am.
Okay, Vijay. Srihari? Okay. So next one is simply ketone. Okay. Ketone means carbon is bonded to doubly bonded to oxygen, but left and right of it, at least one carbon atom is there. Maybe it is simply CH3 and CH3. Maybe it is more than that, like C double bond O CH. 2 CH3 towards one side, the other side is CH3. Anyway, there should be carbon atoms on either side of the C double bond O carbon. Okay, carbonyl carbon atom. Okay, so this is propanone and this is butanone. All right, the number you don't have to specify until butanone, but next one CH3, CH2, CH, sorry, not CH, C double bond O, CH2, CH3. This is pentan 2-one. Okay. Next one, like CH3, CH, sorry, C double bond O, CH2, CH2, CH3. This will be not 2 on here. This is 3 on. Okay, this is pentan 2 on. Okay, clear, all of you? Okay, so this group, carbon simply bonded to other carbon atoms as well as bonded to doubly bonded to an oxygen. This group is known as ketone group. That's it for today's class. Okay, the rest we will see in the next class. Once completed, you can leave.
Thank you, ma'am.
Okay, Sunanda.
Thank you, ma'am.
All right, Vijay. Okay, you can leave, Vijay. All right.